we are going to compare just a few minutes with what we did a few weeks ago when we did the 2-sample t-test. And it's because we did the 2-sample t-test in a slightly different way. Oh, nice slide. Than the way we do the multiple group thing now. But we made a note a few weeks ago that we had something that we called the pooled t-test, 2-sample t-test. We just had a note about it. We didn't really use it. But the reason why we make the note is because some people do use the pooled t-test rather than the Welsh t-test, which is the default by R and the one we've been teaching you. And to make the explicit link between the 2-sample analysis and the multi-sample analysis is via this pooled t-test thinking. The idea of the pooled t-test is, back then, is that is based on an assumption of the 2 variances actually being the same, which would allow us to pool the information about the variability into one number. Whereas the t-test that you were taught to use and that R uses by default allows for the variances to be different. That was pretty nice in the 2-sample case. It doesn't come as easy in the multi-sample case. So we're back in the classical assumption of everything being the same, all variances being the same. Doesn't have to be the case, but that's the only thing I give you in this course. There are also multi-sample versions of the Welsh, but that's for the future for you. Now we only do a multi-sample version of the pooled t-test. In the pooled t-test back in chapter 3, we would compute what is known as the pooled variance, which is nothing more but the mean variance if the 2 group sample sizes are the same. So I have 2 groups, I compute one variance, I compute the other variance, and then I do the weighted average of those 2 variances. That is, if the n is the same in the 2 groups, it's just the average of the 2 variances. And then we learned back then, no we didn't, I'm telling you now, that the F statistic that I just taught you, if you apply that in a 2-group case, because you can do that. The purpose of the whole F and ANOVA is to deal with multi-group cases, but you can use it for the 2-group case if you want. And there is a mathematical exact relation between the F test that I gave you and the pooled t-test from back then. They are exactly the same in this way. The F is the squared t and the p-values would be mathematically exactly the same. There is a point to be made here that for you to think about. I said it already, but here's it explicit. What I call the mean squared error, or the sum of residuals, squared residuals, mean, average, whatever, is exactly the average within group variance, or actually formally the weighted average. So up here in the ANOVA case of today, what I already told you, I told you how to compute this MSE as this sum of SSE divided by n minus k. If you followed me, this should be obvious, but probably you didn't make the link. But I said it a few times, but here it is explicitly, and let me repeat it again. This number, that was the average within group range of data, the average within group fluctuation, the one we discussed in the Kahoot question. I look at the size of what goes on within the group, and I ignore the group difference, but I'm looking at how do they vary within the groups. That's the MSE. And this is mathematically exactly. It might not be clear from the definition, but if you look a little at it, it's not difficult to see that it is exactly the weighted average of all the individual variances computed within each group. So I can take each group, compute the variance as you were taught on day 1 of this course, apply that formula for the variance within each group. I have 5 groups. I use the formula from day 1 5 times. And then I do the weighted average, and if the group sizes is the same, the simple average of those 5 variances, and I would have the MSE from my analysis of variance purpose. So actually already on day 1, you were taught how to compute the denominator part of a multi-group analysis of variance, because it is just repeated computations of variances and then combine them. So just to make this link, what is in the denominator of this fancy ANOVA thing that you learn today is nothing more but what you were taught on day 1 and then combined from a number of groups. Anyway, so we have this link between the 2-sample and the multi-sample case. We need to work with this assumption of homogeneity. That was one point made. Yeah, no, not now. Later. Not there. There we were. Are you ready? What's going on out there? Anyway, you only had a few minutes to think about this. The residual variance, the sigma of the model, actually. The variance parameter of the model, if we want to be formal about the statistical, the sigma, which was in the model expression. The estimate of sigma is MS for residuals. That's the MSE. The MSE for these data is 1.545, and the MSE is the sigma hat squared, the variance estimate. And that was what I asked about, or expressed here. The residual variance is 1.545 and nothing else. And the other ones are purely rubbish. That's the fun thing about making multiple choice exams. That's finding all those wrong answers and having a laugh. Sorry about that, but hey, we need to have fun about something in my job, right? So laughing about things is sorry, that's not a good. Of course, I don't laugh at you answering wrongly. I feel sorry. No, that's not either. Anyway, let's move on. And still fertilizer. There we are. Next time you'll do better. That's the purpose of it.